Assalamu alaikum. Today it's a sixth lecture of a DSP. Today we are going to discuss about a sampling theorem and the characteristics of a filter. And we also know that a sampling theorem is a 2 times of a maximum frequency. And we have a signal which is a continuous wave. In this, if we want to sample function, then we multiply with the pulse train. Pulse train is a sum of individual pulses, and then we multiply it with the original signal and we get a sampled function. In sample function we have a different in the sample signal we have the discontinuous values. That's why we are discarded other values. If we get our original signal, then we pass through this sample function through the low filter and we get our XFT. It's our original signal. Now we will see how the shifting of a signal depends upon the conversion of a discrete Fourier transform. And we have a signal in which the first value is 1 and the other all values are 0. When we find x of k by this formula, discrete Fourier transform formula, then we get all values is equal to 1. And we take another signal x of n in which we shift one step and we get all these values by using discrete Fourier transform formula. And we take another input signal in which we shift two values and we get all these values by using this formula. And we know that impulse function value is 1 and 1 is 2 pi p of omega, and the last one is ej if it's exponential form, and then a 2 pi sigma omega minus omega naught is a transform function. Now we will see how the shifting function affects on the convolution. And we have an input signal and we have an output which is equal to x of n convolve with y of n, and we get a output 1 2 3 0 and 2. And we know that the value 2 at point 0, as we in our input signal as the value 2 at point 0 and the value 1 at point 0, and the shifted function with by factor 1 impulse n minus 1 which is equal to 0 1 0 0, and we have a output x of n convolve with the shifted impulse function, and we get a output z of n 1 2 3 0 and 2, and we have on point 0 the value is 1. Now we will see if we add one time delay, then after convolving we get delayed signal. On the other hand, if we add 2 time delay, then after convolving we get delayed signal by factor of 2. Here x of t converted to x of omega and p of t converted p of omega. Here is a p of t which is equal to summation n is equal to minus infinity to infinity, in which we have a sampling time and a sampling. Here we get a sampled signal and a sampling time, and we get a desired formula p of t summation k is equal to minus infinity to infinity a k e की power j omega naught kt. Here is a k is a 1 over ts, and the final formula s of omega which is equal to 1 over ts sampling time multiplied by omega minus k omega s, in which delay in delta result delay in the signal. Now we have a omega b and a minus omega b. When we pass through the filter, then we get a different signal on a different patches. If overlapping, then omega s minus omega b greater than b, and other one is omega s greater than 2 omega b. Thank you very much. That's all for today.